Okay, so we have a rational inequality here. We have two fractions on both sides of our inequality sign. The first thing we have to do, just like for polynomials, is we want 0 on one side of our inequality. So I'm going to move everything over to our left side. And then to analyze this, much easier if it is one fraction. So I'm going to get my common denominator. Just a little reminder, right? So that means we're multiplying this guy by x plus 6 over x plus 6, this guy by x squared over x squared. And I'm going to try to kind of combine some things at once. So I'll have x plus 6 in the numerator here, minus x squared up top. And then my denominator will be the common denominator here. So x squared times x plus 6. Okay, so just cleaning this up, I'm going to do this in one step. I'm going to pull out the negative and just rearrange everything. So I'm going to get positive x squared in here, minus x minus 6. And the whole goal of this is to be able to identify any vertical asymptotes and zeros or x-intercepts, because those are going to be our critical points. So now I can write it in my final factored form, and I'm going to do that up here in purple. I'll get negative, looks like I'm going to have x minus 3 and x plus 2 over my denominator factors. All right, so I'm going to approach this the same way I did polynomial. So I'm going to create a number line, and I'm putting on here vertical asymptotes and x-intercepts. And I like to, on my number line, kind of clarify what is what. So for example, I'm going to put 0 from our denominator, that x squared, down here. And I either like to write like vertical asymptote or 0, or you guys can see I drew it as a dash on the number line. But make sure you kind of have some way of knowing what is what. So I got that one on there. I also need negative 6 as another vertical asymptote. And then my x-intercepts from the numerator. So I've got a negative 2 and a positive 3. And I usually just put those on as like dots, actual intercepts to go through. Okay, so for these, sometimes you can think about when things are positive, negative, and go through, but it's not like a polynomial where like we have a highest degree or a multiplicity or kind of, we would think positive, even, positive, odd. So I like to check a zone by either subbing it into our factored form or really into any form. I'm going to go back and use this form over here when we had just moved the fractions on one side. So I'm going to check, I'll use positive 1 since 0 is an asymptote. I can't put that in. So I'd have 1 over 1 minus 1/7, and we would want to know if that is greater than 0. And it definitely is. So I checked 1. So in the zone where 1 is, that's over here. Everything's moving. I know the graph's going to be positive. And I'm going to circle that because those are the answers we want to take since we want to know where it's greater than 0. Now, a couple ways we can finish off this problem. I can go through and check all the zones, or we can still use multiplicities, right? At all of these zeros, I'm using an eraser. My multiplicity is 1. And even underneath, maybe I'll write multiplicity 1 for 0, multiplicity 1. So it's going to cross through the x-axis, for example, at positive 3, and the graph would become negative, right? Because our multiplicity was 1. The same thing applies for vertical asymptotes. So at 0, we've got multiplicity 2. So I'm going to write that underneath, multiplicity 2, which means my sign is going to stay the same there. So this guy is going to be positive also. But we said negative 2 is multiplicity 1, so we're switching signs. And negative 6, another multiplicity 1, so we're switching signs. So I have all the zones where we're positive. I only want greater than 0 now. So we can write our final answer in interval notation. So negative infinity to negative 6. Negative 2, I still need to break it 0. I'm not allowed to have that on the graph. And then 0 to 3. And you can always check by graphing right now. You can see that these are actually greater than 0. You can check other values in the number line and go through with those.